Very good morning to all. Today I am here for giving a lecture on production of low pressure and temperature. This is for BSc second semester students. So today I will start with introduction in this chapter. So production of low pressure and temperature, it is one of the technique help for so many application in sciences. Science, we know science is consisting of so many branches. Mainly I will explain about in which area it is helpful. For in area of, it is helpful in the branch of CRT, that is cathode ray tube. It is helpful in electric lamp. It is also helpful for thermonic valves. It is also helpful in X-ray tubes. That mainly I explain about this one. Next, it is also helpful for designing the various pumps, for example diffusion pump. This production of low pressure and temperature, one of the scientists, that is German scientist Gied, is the scientist introduced about the first pump, that is rotary oil pump. Next also he designed the rotary mercury pump, and also he given the 1915 diffusion pump. What is the purpose of designing this pump? What is the purpose is that as much as possible the reducing the pressure, you creating the low pressures around the range is 10 raised to minus 5, 10 raised to minus 6 mmHg, that is millimeter mercury. So next, it also helpful for measurement of pressure. You develop or design the gauges or sensitive gauge. These all are about the introduction of production of low pressure and temperature. Now I will going to study about exhaust pump and its characteristics. We can see in industry or in home, at a particularly kitchen, you fixed the exhaust fan. Same, what is the work is done by that fan, same in exhaust pump also. It reduce the air or a gas from the vessel. Let us, there is a container, there is a room, it consisting of air or a gas. I want to remove the air from or a gas from the vessel. You kept the exhaust valve or exhaust pump. So getting what is exhaust pump? It is a pump or it is a device. It remove the air, it remove the gas from the vessel. This is known as the exhaust pump. It having a three characteristics for the exhaust pressure. So in exhaust pressure is consisting of inlet valve. So inlet valve, air is taken inside that one. After that, it also consisting of outlet valve. It consisting of exhaust side, the air drawn from the vessel, and it is expelled or it is go outside the or move outside the air or a gas from the vessel. Next, what is the exhaust pressure? It is a pressure is exerted, or it is referred as to expelled. Next, this exhaust pressure is equal to the atmospheric pressure. What do you know about the atmospheric pressure? The pressure exerted by the atmosphere, that is the atmospheric pressure. The exerted pressure, that is equal to atmospheric pressure, or it may be less than the atmospheric pressure. Next, degree of attainable. Degree of attainable vacuum, it is a second characteristic of exhaust pump. This is defined as the lowest pressure it may be attained in a closed system connecting the pump. So if you connecting the pump in series order, the lowest pressure or limiting pressure is exerted in closed system. So if this lowest pressure, this limiting pressure, it depends upon the exhaust side or outlet side. So this is a degree of attainable vacuum. Next one is third characteristics, that is speed of the pump. So this is defined as the reduction, the rate of reduction or removal per unit volume. Per unit volume, at a particular volume, how much is the reduction, how much is the removal of pressure is known as a speed of the pump. So there is a mathematical relation about this equation, that rate of reduction per dP divided by dt, that is equal to S. S is the speed of the pump. Next, P minus P naught. Here P is the pressure at a particular interval of time, minus P naught. P naught is the pressure, limiting pressure or lowest pressure. Next, divided by per unit volume. V is the per unit volume. So next, I rewrite this equation. I have taken the pressure expression in left hand side. So I already told that one. P minus P naught I have taken left side. So minus dP divided by P minus P naught is equal to, as it is, as divided by V into dt. So negative sign, because the pressure is decreasing, reducing the pressure, that's why negative sign is came here. Now I integrating this above equation, and also before that having a initial pressure is P1, at that time T is equal to T1. I taken a time T is equal to T1. After some time the pressure is P2, in that time T is equal to, we can take as a T2. Now integrating this equation, we get log, because same pressure, so automatically minus log P minus P naught, upper limit and lower limit are applied here. So that is P2 P1 SWV. Here integrating that only we get T. So T1 T2, applying this here, applying lower limit, because minus I want to remove this minus, that's why first I apply lower limits. Log E P1 minus P naught divided by P2 minus P naught is equal to S by V. Apply first upper limit T2 minus T1, because no negative sign, so we can, as per rules, T2 minus T1. Next, S is equal to just cross multiplication, V divided by T2 minus T1 log to the basic P minus P naught divided by P2 minus P naught. This is the equation number 3. So limiting pressure or lower pressure, that value is can be neglected. Next, X is going to be T2 minus T1 log to the basic P1 divided by P2. Here P naught, they are neglected. Next, I taken some simple values, that P1 divided by P2 are considered as a E, and T1 minus T2 are considered as a 1. Next, remaining value is log E divided by E. Here P1 divided by P2 are considered E. That's why in logarithmic equation, log E to the base E is equal to value is 1. Next, the actual exhaust speed, that is at an instant, is according to Lagmore, is one of the scientists, is given that E is equal to, or exhaust speed is equal to, volume per unit pressure and rate of reducing the pressure, that is V divided by P, and reducing the pressure dP divided by dt. Next, there is a relation, product of pressure and volume, we can write as a P. So pressure, that is pressure is decreased, that's why P minus dP, that is change in the small change in the pressure, that is negative, and into volume, there is an increase of volume, that's a V plus dV, increment of volume. Next, I am multiplying PV as it is. Next, I am multiplying this one PV into V. After P is equal to dV minus, I am minus dV, V into dP minus dP into dV. So here dP minus dV are small, so just you are neglecting that. So small change in the pressure, small change in the volume, that's why they are neglected. PV get cancelled. Remaining term is P into dV is equal to V into dP. Next, I write this dV is equal to again V divided by dP P into dP. Next, both side I taken the dt value, that is differentiating. dV divided by dt is equal to V divided by P into dP divided by dt. This is the equation 5. This is the equation number 4. And also there is an equation that E is equal to dV divided by dt. Exhaust speed is equal to dV divided by dt. Substituting a dP and dt value here, dP and dt value in equation 4. In equation 4 is here. Now I write this equation. E is equal to V by P as it is into dP and dt value equation 1. Already you know about that. Put that value. Next, E is equal to we get cancelled. S is equal to P minus P naught divided by P. So P is base for both equations. P gets cancelled, only 1 minus. So 1 minus P naught divided by P. S is outside. So this is the expression for exhaust speed. So hope you can understand what today I discussed. Thank you so much.